Purdue University was founded in 1869 as a college for science, technology, and agriculture, and today enrolls 40,000 undergraduate and graduate students in over 210 major areas of study. Purdue offers more campus computing cycles to faculty than any other university, and it operates the largest academic distributed computing grid. By several measures, Purdue's Rosen Center is a national leader in developing cyber infrastructure for scientific discovery.
The first cluster we built was composed of, I believe, 24 nodes per rack and consumed about 8 to 9 kilowatts per rack. And we cooled them with fan doors, basically a big fan on the back of the rack, which exhausted the air into the room. And they found that they were right on the edge of OSHA regulations, 85 decibels, because of the noise generated by the cooling doors. When you actually opened the rear door in one of the racks, the level went up to 100 decibels, which is way above OSHA regulations.
This is one of the old fan doors that we used to have on our previous clusters. When we had a room full of these, we wouldn't even be able to have this conversation.
To provide more large-scale computing, Purdue was deploying a 1,500 node expansion with increased rack densities.
We have a traditional data center with Liebert-style crack units, they call them, around the periphery of the room. That particular cluster was pushing our limit, and we had an envelope of 14 to 15 kilowatts per rack. Some of the other options had compressors involved in them. They'll operate at a low enough temperature, they'll condense water out of the air, and we've had too many problems with the regular computer room crack units to want to go down that road if we could avoid it. So that was one of the interesting options that Coolcentric had. It monitors the dew point and keeps you from condensing water out of the air. The operating cost of the fan door configuration over the life cycle of this expected cluster came to around $70,000 versus the operating cost of a pump-based system like the Coolcentric, which pumps water. There was a tremendous difference in just the operating cost.
This is one of our traditional crack units. We used to have 8 of these in the room. On the equipment we had before the Coolcentric, it was just barely handling the load. And when we put in the Coolcentric, we removed 4 of the crack units, and we're now running just fine on 4.
John Campbell, Associate Vice President at Purdue's Rosen Center for Advanced Computing, said,
"The IBM and Coolcentric solution came in at a lower price than any other option, and in many ways offered a nice flexibility and match with our existing infrastructure."
We had to take into consideration aging infrastructure of the university. Our chilled water plant is probably typical of many universities. It's in cases 100 years old. It feeds over 100 buildings. The water quality of the plant was an issue with several of the vendors. Coolcentric was able to satisfy the water quality issues. Reliability was another factor. There's no moving parts in cooling door, whereas the fan door units, of course, have moving parts, and that's always a failure point. So this was another reason to not go with that style of fan door in the future. Another point in the favor in choosing the Coolcentric over some of the other options. A lot of people worry about water in the data center. I've been in the industry for over 30 years, and many of the early machines, IBM, Unisys, all the mainframes of our youth, used water cooling, and the technology has well developed and very reliable, and we have never had a problem in our experience with it. If you have crack units, if you have water in the data center already. We change vendors of machines potentially every year since we go out for competitive bids. Some of the manufacturers' racks are not compatible with other people's nodes and vice versa. One advantage of the Coolcentric we discovered is they are mounted on the racks with a transition frame, which is simply a narrow piece of metal, and that can adapt to many different rack vendors, so we have some flexibility there. In fact, our last purchase, our storage system required extremely deep racks because the disk trays are very long, and we were able to use a standard Coolcentric door.
John Campbell concludes,
"The importance of the solution is that we are now able to continue growing these research clusters to support scientific diversity and to offer new insight into some of the toughest problems that we face as a country and as a people."
there's no way we could cool our data center reliably with the power density that we have now with the traditional crack units, considering the hundreds of nodes we have. So the Coolcentric looked like the best bet to be able to handle that, and it did.